Fantastic. So, good morning, good afternoon. Hello, everyone. Thank you very much for joining our very last webinar focused on either education or rather professional development for 2024. We are very excited to introduce our panelist, Dr. Stephanie Proano. She is the applications scientist at Cell Microsystems. In her current role, she is developing the commercial operations and scientific applications for automated patch clamp and shear flow instrument solutions. Before transitioning into industry, Stephanie completed her doctorate at North Carolina State University, where she studied sex and estrus cycle dependent differences in the electrophysiology of medium spiny neurons in the striatum. Following her doctorate, Stephanie was a postdoctoral fellow at the National Institute of Environmental Health Sciences, where she investigated the role of sex and estrus cycle-dependent differences in the expression of hippocampal region CA2 specific genetic markers and their impact on the electrophysiology of pyramidal neurons in the brain region. Through her doctoral and postdoctoral work, Stephanie found a passion in championing the inclusion of women in science, both in studying their biology and by fostering spaces in industry and academia where women feel included and represented. So, Stephanie, we are very excited to have you as a panelist today, and I will give the floor over to you.
Thank you, Michaela, and thank you so much to the organization for having me and for asking me to talk about industry, a little bit different from some of the talks that we've had, but I think that I hope I can give you some insight into how that transition was for me and a little bit into how pretty much that transition goes in general and some things to look out for and just general things like that. My presentation is not extremely long, and I did that on purpose so that if there are questions, we have enough time to talk about those, since this is an area that's not often talked about, even though the majority of us who go to grad school do end up in industry positions. So with that, I'm going to begin, and I'm going to talk a little bit about my journey and how I ended up where I ended up. So I started in academia, as Michaela mentioned from the introduction. I did a doctorate, and then I did my postdoc work. And I think that, during this time, I was training on how to become a bench scientist, how to use the scientific method, pretty much the experience that many of us here share, right? For me specifically, I was interested in electrophysiology when I started, and that's what led me to the lab where I worked at, with two labs where I worked at in my doctorate and then also in my postdoc. So I specifically focused on whole cell patch clamp electrophysiology. And as a complement to that, I also learned how to do other lab bench techniques like ELISA and transcriptomics and things like that. So when I was in my postdoc, which happened to coincide with COVID, I think that going through that experience, trying to become a more independent scientist at a time when the whole world was having challenges, I think that put many things into perspective for me. And that's what led me to try to find something in industry, right? And for me specifically, I had no real training on what that would look like. So I had to do my own research. And so my first job out of industry was in a contract and development manufacturing organization because I thought that was the option, right? You're in academia and you either go to biotech or you go to pharma. So I was basically in pharma. So my first job out of academia was as a scientist at a CDMO. And this was this was a very tough transition for me because the mindset was different, right? I was working under GMP, and that usually means greater manufacturing practice. So you have to be very careful about how you document everything. And a lot of attention is put more on that rather than the actual science. The science was already developed, so I was just following assays, and that was pretty much the experience. And if anybody here has done wholesale patch clamp, that is a very messy technique where you learn to troubleshoot. Troubleshooting is your everyday life. So doing assays, the same assay every single day of your life, coming from a wholesale patch clamp world, it was a little bit boring for me. So there was no troubleshooting, there was no real thinking about the science. So I knew that this wasn't the right position for me. But it was great, as it was a great starting point because I started to learn more about industry and more about what I didn't really like or where I didn't envision myself within this world. So after that, I started as a field application scientist at a startup. And this brought me back to electrophysiology. So I was a field application scientist for a system that is microelectrode arrays. So it was great to come back to my electrophysiology background. And this was a great position because I got to travel a lot to help scientists all over troubleshoot their experiments, teach them how to use an instrument. So it was nice to get to do other people's science without the pressure of having to make it work. And I think we can all appreciate a little bit of that. And now I am an application scientist at a startup again. And this opportunity presented itself as a way for me to actually have more of a say into how to develop an instrument. And in this case, is a whole cell patch clamp robot. So it's pretty much taking what I learned in grad school and automating that process. So that's where I am right now. But as an application scientist, this role is very different from RD, just solely RD, because then as an application scientist, I have to speak with customers, I have to speak with stakeholders, and their input as well as market research informs the way in which I develop scientific applications and also in the way in which the instrument gets developed. Okay, so that's pretty much kind of my story. And as I was mentioning, my motivation for shifting from academia to industry happened during COVID. And this is where a lot of personal, professional, and financial goals came into play for me. I think that this time gave me a lot of time to think about what I really wanted out of my career and out of my life. Okay, so this was very in a nutshell, this was a very personal decision. And if you're thinking about making this transition, you should think about all of these different aspects and where you're willing to, give in a little and where you're not. And that will help inform whether a transition to industry is the right transition. I know for many people, there's the financial motivation, but that, for me at least, that wasn't the whole picture. So you have to kind of evaluate your life, where you're at right now. And as I said, where are you willing to give in a little and where you're not? So where are your boundaries in terms of what you want out of your professional and personal life? Because I think that as much as we try to keep those separate, they always intertwine. So when I was thinking about transitioning to industry, I made a list of pros and cons. And now that I have more of an insight into industry, I've been able to refine this list a little bit. So that's what I'm about to share right now. So in industry, some of the pros are the higher salary and the benefits. And this will largely depend on the role that you get. So one of the things that I didn't know about industry is that there are so many different roles and opportunities for people with a master's or a PhD, or even just coming out of undergraduate. And your salary and benefits will depend on what you do. The impact of your work is more immediate and direct. And what I mean by that is that in industry, all of the projects are they tend to be short term. So you get to see whether a project works or not very quickly. And if it doesn't work, then those goals get changed constantly. But if the project does work, you do see that immediate impact into, the whole workflow of the company, into the revenue of the company, and even into people's lives. There are many projects that are directly impacting the therapies that we develop, for example, and that has a clear direct impact into what your work influences, right? The career progression, this is a very big umbrella expression in my opinion, because that's not to say that there's no career progression in academia, but in industry, the ladder tends to be longer. So there are more opportunities for you to advance, or to, even if you don't, move upward, you can still move laterally. So there are a lot of different ways to make career progression happen, especially in larger organizations where there are jobs for nearly everything. You get to choose pretty much how what skills you have and how you apply them into whatever role you want to get. So there is a lot of flexibility in where you can move. It could be upwards, it could be lateral. It's really up to you. But there's a clear structure in most companies, whether you can start as a scientist one, you move on as a scientist two, and then you become the lead scientist. And from there, you can then pivot and go into becoming a director. So there are different steps for that progression. In academia, we tend to go more from, I think it's from associate to assistant to full professor, right? And then for those professors who want to keep going, they can go into becoming a dean or more admin work. But in industry, there's just a lot. And that is something that was not very clear to me at the very beginning. There are more career opportunities outside of the lab and of teaching. So in industry, you have the R&D side of the house. That is where the lab work lives. For me specifically, as an application scientist, I have one foot in the lab and one foot in the commercial space of the organization. So I'm kind of inhabiting both worlds. But other than that, there are so many other positions that are completely outside of bench work that are fun, and it can also be just as fulfilling, where you do get to apply your scientific knowledge. You may not be doing the experiments yourself, but you are kind of working as a consultant for an organization and bringing in your expertise of how things should develop. Another pro about industry are the resources and funding, and this depends on the organization, right? So there's this perception that in industry there's always money, there are always more resources, but that tends to be the case in organizations that are much larger and more established. In startups, which is where I've come to inhabit, these resources will shift, because especially if the startup is just an early startup where the revenue goals are not being met, and all of the funding comes from venture capitalists or from investors, from a board, those resources may not always be available. And then at that point, it's very similar to academia, where you're trying to make ends meet with the money that you're given through grants, right? So keep that in mind. The resources may not always be there. And also work-life balance. There's also this perception that when you move to industry, you won't have to put in so many hours in the lab to get, the projects to work. And this will also depend. If you're in a larger organization where your job is very well defined, you know exactly what you're going to do from 9 to 5. And many times, depending on what you do, you will not ever be asked to work on a weekend or work after hours. This will also depend on whether or not the goals of the project are being met. However, in smaller organizations like startups, work-life balance can get a little bit tricky. And this can also be very similar to an academic setting, where if you need to be in the lab, for example, or something happens, everybody needs to come in, and it could be on a weekend, it could be after hours. So it really just depends on the type of organization that you're at, and also on the culture of the organization. So, for example, in the first startup where I worked as a field application scientist, the company was further down in the revenue targets. So we were closer to meeting revenue goals. And because of that, there was more flexibility to say, you know what, I'm not going to work on a weekend. We can do this on Monday. And that was generally okay, right? Where I am right now, which is a very early startup, because we're so few people and we wear so many hats, there have been times when I have to go in and work on the weekends or even after hours just to meet goals, right? So just keep that in mind. This is work-life balance depends on the organization. It also depends on you and on the boundaries that you want to set. Okay. And this is true in academia as well. Okay, so some of the cons of industry. So there's absolutely less intellectual freedom. You don't really get to choose what you want to do the R&D work on or how you want to develop an instrument or where you want the organization to go. This is all very much determined by the board, by the investors, and by market research. So if you're thinking of doing, you have this amazing idea of developing a scientific application, which has happened to me, um, but then you start to do the market research, you talked with the stakeholders, and if there is no real path for revenue for that project, then the answer is going to probably no, you can't do that, right? You have to find projects and you have to work on projects that will lead to revenue, because once you're in industry, it's not about knowledge so much. It's about what makes us money, what is going to be profitable, and what will give us revenue. So that was a very different mindset as well. There is a lot of pressure for results. So timelines in industry are much shorter than they are in academia. And this could be fun for some, and it could also be a challenge for others. I particularly, I had trouble with this at the very beginning, but now I love it because I know that I have a clear goal. I know that I have to deliver and it'll be done in a couple of months. And after that, we can move on to the next thing. So you get to do work on many different projects, but there is that pressure to deliver results, right? And if the results are something that will not support revenue again, then the decision's probably going to be made that that project is going to be discarded and you're going to have to move on to something else. Okay. Job security fluctuates a lot, and we've seen that I think a lot over the last 2 years. The market has been a tough market. Right after COVID, the market was strong, everybody was hiring, companies were expanding. But as we've come out of those early pandemic years, companies have realized that, maybe we didn't need as many people as we did before. Maybe we shouldn't focus on all of the projects that we had during that time. So the market has contracted a lot at this particular time. So, and this is not something that is happening right now. These are things that happened before during the recession in 2008, right? So the job security fluctuates with how the markets are reacting. So that is something to keep in mind. And I think that in academia, and I'll speak about that in a moment, once you find that position, it is much easier to stay in that position and to have more stability. That doesn't necessarily happen in industry, okay? And in industry, the jobs that get impacted the most depend, right? So what we've seen, one of the trends that we've seen this year, for example, is that R&D jobs were highly impacted by layoffs. And that is because once stakeholders realize that, for example, a particular R&D project is not going to be commercially viable, it's not going to generate the revenue, usually those whole sections have to be cut. Okay, so that is something to keep in mind always. The job security will fluctuate, especially early on in your career. The more you're established in any industry, not just science, the more secure you are in your job. So definitely keep that in mind. And another con, it could also be viewed as a pro, is that in industry you have more specialized roles. And this is true of larger organizations like CDMOs, CROs, pharma. The jobs are very well defined, and a lot of the times you can't step out into another, you can't do the job of another role per se, right? You have your job, you know what you do, and that is what it is. So it could give the perception that everybody's very siloed into their positions. This is not necessarily true in the startup environment, where, as I said, you have to do a lot of everything just because startups have less resources in terms of money and in terms of people. Okay, so the pros in academia, there is intellectual freedom. You can choose pretty much what you want to work on, what you want to do your research on. You can find your passion that way, right? For me, when I was in academia, it was understanding female biology and specifically what ovarian hormones do to the female brain. I think that for all of us women, we know that as hormones fluctuate during that monthly cycle, we feel different, we act different, our brain is working differently, right? And that is something that I was passionate about back then, and I'm still passionate about to this day. I don't think that'll ever change. And I think that we need to do more research to understand the female body, period, right? So when I was in academia, I had the intellectual freedom to say, this is what I want to work on. Of course, you have to tailor your project to the needs of the lab that you're working in, or you tailor your projects to the lab that you're starting, right? But you choose that, okay? So there is that tied to this is the pursuit of fundamental knowledge. You can do that absolutely in academia. In industry, as I said, the projects are determined by commercially viable goals. There's also more job security, and I say it depends here because it really depends on the position that you end up in, right? There are, for example, I have many friends who are doing adjunct professorship positions, and those tend to be more temporary, more short term. So that job security depends, but there is more of that, I feel like, in academia as opposed to industry. There are flexible schedules, and I say depends because, again, I've been in the lab really late. When I was in academia, I had to do recordings for my experiments overnight once because I was tracking the ester cycle. So the flexible is, that really depends. But from the friends that I have who are professors, they have usually those appointments are 9-month appointments, and then they get to choose what they want to do, for example, in the summer. So that flexibility is not really there in industry. In industry, this is a 9 to 5 job that lasts 365 days of the year, right? So that is definitely a pro of academia. And some of the cons are the funding situation that, at least in the United States, that depends very much on our government and, where the science is going, right? If you're thinking about doing a far-fetched project, there might not be enough funding for that. So you always have to kind of think about what the research community is kind of working towards and then write your grant about that. And that is pretty much how you get your funding. The salaries also tend to be lower. But again, in many cases, these are 9-month positions, right? So you have the flexibility to either work over the summer, you could teach over the summer and then make up some of the money. If you're a teaching professor, for example, if you are a research professor, you can get more of that money through grants as well. So you do have flexibility in how you combine and how you make your salaries a little bit higher. But in general, salaries are lower. The workload can be a lot. You have to be in the lab doing experiments. And for many of us, those experiments depend on our animals, on our cells, and they are on their own cycles. They don't talk to you about whether or not it works for your schedule or not. You just have to be there when things are ready, when the biology is ready. And also funding, right? You have to constantly write grants and writing reports and giving presentations, and also if you have a teaching load, and depending on how big that load is, you might have to put in time into making classes, organizing classes, meeting with students. So the workload can be big, but that can also happen in industry. Okay. As I said, in larger organizations where you have more specialized roles, you know exactly what you do from 9 to 5, and then you can disconnect. In a startup environment, especially if you're in an early startup like I am right now, the workload is big because you just have to make things work, right? You're trying to hit revenue targets, and you're trying to convince the board and the investors that you indeed are a viable company that they should keep investing on. So the workload can also be pretty big in industry. Another con is that there are fewer academic positions than there are positions in industry. As I said, in industry, you're not tied to the lab bench. There are positions outside of the lab, and there are a lot of those. Okay, so But in academia, the professor positions, the highly coveted research professor positions, there are just fewer, and that's just a reality of it. So competition for those is bigger. Okay, so how did academia prepare me for an industry role? And I think that this is something that, especially if your program doesn't incorporate classes on industry and on, for example, resume writing and how to prepare for a career outside of research or and of academia, we don't really get to think about how the work that we're doing in the lab is really preparing us for a career in industry. And I am a big proponent that it is preparing us. We just have to kind of look deeper at what we're learning as we're doing our research projects. So, first and foremost, we do get rigorous training in technical skills. In my specific case, it was electrophysiology and other lab skills, right? And it, for me specifically, electrophysiology has been what kind of has propelled me in my professional journey because I have this skill because electrophysiology is not something that everybody does. I was able to land the positions that I've had. Um, but another thing that we don't really think about is that we are very good at problem solving and critical thinking. Like we are the preeminent critical thinkers, right? Because we have to, as we're in academia and we're designing our projects and we're thinking, about the paper that we're going to write and how to interpret the results that we're getting, we are exercising our brains a lot. So we're very good at problem solving because we also have to use the limited resources that we have to make things work. And we are, as I said, the preeminent critical thinkers. And that is something that industry values a lot, especially in startup environments where you do have to find solutions to many different issues that arise. You exercise that a lot and you have it. You're also very good at managing projects, especially, in academia, we start out and then we have our whole research project that we dedicate our lives to during those 4 to 6 years, right? And we're managing that project. At the beginning, we might get help from our PI if we're lucky. Other times we're just thrown into the wolves and we just have to make things work, right? And we have to manage those projects and manage the deadlines and plan our lives essentially. So we are very good at project management, and that is something that is also very valuable in industry. You have to know how to manage a project, you have to know how to manage your time. And it is this exercise that makes you a valuable asset to your company. And we have that as PhD students or as master students who are doing a research project, right? We know how to manage projects. And with that, a lot of the times we get the help of undergraduate students, for example. So we also know how to manage people and how to ask them and delegate certain tasks, which is also something that you're going to definitely need in industry, right? There's usually, if you have a PhD, more than likely, you're going to start as a scientist 1 or as a research associate 3, and you're going to have people under you, and you're going to need their help. And already how to delegate those tasks and how to manage the project and how to tell people, I need your help with this so that I can do this, right? So we know how to do that. And another big one, a huge one in industry is communication. And again, we have that because a lot of the times we have to teach. So we have to find ways in which we can deliver complex information to people who are probably getting exposure to this information for the very first time. We know how to do that. We also know how to present scientific content to broad audiences, right? So we're not just talking to undergrads, we're not just talking to our peers in the lab. There are many people who start in science communication while they're grad students or postdocs. We know how to use language, right, to convey the messages that we want to convey. And this is huge in industry. There have been many times when I've been in hiring boards in the companies where I've been, and you can have all of the technical skills that you want to have, but if you cannot convey that information to me, that makes it tough to decide to move forward with an offer. But we have this. We are communicators, right? And again, technical writing, we have to write papers, we have to write reports, we have to write grants. So we know how to do this. And this is something that's also very valuable in industry. You have to know how to communicate verbally, and you have to know how to communicate by writing. And we have these skills. This is something that we exercise pretty much through our entire careers in academia. So lean on these so that you can move forward to your industry role. And this is something that you can absolutely list on your resume. Okay. Another big one is collaboration across disciplines. I think that one of the trends that I've seen is that as funding has contracted, we've had to become more creative in how we make projects happen, right? And one of those ways is to find collaborations. My lab may not have certain resources that your lab may have, so we can collaborate. You know, I can provide the electrophysiology, and you can provide some other lab skill that I'm interested in, maybe behavior, right? So we have to, this is an exercise of bringing people together, talking about what each can give and how to make a project happen. This is my daily life in industry. So because I'm working on developing the instrument, the automated patch pump robot, I have to collaborate with our software team. I have to collaborate with our engineers, and I'm the one that's in the lab. I also have to collaborate with the marketing team so that we can decide on which material to put out into the world, and then with customers who have some of our early units, and get their feedback and then implement that into the development of the product. So again, as scientists in academia, we know how to do this. And even if your lab is not collaborating with another lab, you're still collaborating with people in your own lab, right? Everybody has probably similar projects, but they're achieving different goals. But your projects are more than likely complementary to each other, so you are still collaborating, right? So this is something that can also go on your resume, and this is a skill that you would definitely have to lean on if you do want to make the transition to industry. Some of the missed opportunities that I myself, this is very personal, found in my graduate program in regards to industry was that I never got exposure to understanding industry. As I said, I thought there was, academia, and I knew what that trajectory was like because that's what I was surrounded by, right? My PI, he went through that track and he knew how to give me advice about that. But I didn't really have exposure to anything other than that. So I did not understand how industry worked. I also had no knowledge of all of the possible industry roles. And as I said, there are many. So do your research. If you're thinking about making the transition, there are so many roles. Just, do your research. We're good at doing research. So find what you think would be a good fit. I also had a lack of exposure to industry professionals. I pretty much knew no one who was in industry. And I think it's very valuable to talk to people who are in industry and who have a particular job that you're interested in and just talk about their experience. How is your day to day like? How did you get to where you got, right? Those are fair questions, and people are usually happy to talk about how their life is like, right? And what their role is like. And I think that in academia, there is a big focus on technical skills, and that's mostly where it is, right? You're trying to create this research project, trying to find an answer, find the knowledge. And to do that, you develop all of these technical skills. But in industry, that is not the full story, right? In writing, in paper, on paper, your CV may show that you know how to do ELISAs, that you didn't know how to do transcriptomics, that you know how to do electrophysiology. But what usually tends to happen in industry is that you as a scientist will show up and it'll be a new different kitchen, right? If I tell you to come and cook in my kitchen, you will not find anything more than likely, right? Because everything is in its own place, and every lab has their own way of doing things. So you're going to have to get retrained on these skills. It's great to have a baseline, and you do have that baseline because of the work that you've done in academia, but you're going to have to be retrained on how to do something, right? So your technical skills are part of the story, but they're not going to be the full story. The full story is going to be what I had in the previous slide. So it's going to be your communication skills, your ability to work with different teams, So think about those and definitely add those into your resume. So bridging the gaps. So what are the things that kind of bring academia and industry together? So as I mentioned, it's definitely communication. There is collaboration in industry, especially in startups and in companies that are not necessarily pharmaceuticals. Pharmaceuticals tend to be more restricted, but there's this mindset of teams, right? Everything is a team. There's a team for everything, and you have to cross collaborate with all of these. So that is big. You do, and I say business acumen here, even if you don't think about it as an academic, you're still, when you're trying to create your research project, you first of all, it has to fit under the umbrella of what the lab wants, right? But then you also have to think maybe about where we're going as academics. Where is the field going? What is the new technique, or what is the new frontier, right? With the opioid epidemic, for example, that became a large area of research. So even though that's not a market in the traditional sense, right? For an academic, it is still a market, right? If you do research into this, for example, that has led to so many companies starting or creating therapeutics for opioids. So you do understand where the field is going. So that is essentially your market research. So that is what you can pull from to kind of get some of that business acumen. And again, what are the customer needs? That is very specific to industry. But as an academic, as I said, you know where the field is moving to. You know what, the everybody within your field is trying to understand and do the research to solve a problem about, right? So that would be where you bring in that acumen. And you can take that and how you keep up with your field and apply that to how you would do market research in an industry. Like, is this a viable scientific application? Do people even care about this? And if they do, why do they care about it? Is it that the government provided more funding to understanding the different receptors that mediate an opioid addiction, for example? It's a very similar exercise. Another big thing is you have to be very adaptable, right? So there is in industry, usually you will learn about new tools and new platforms that have to be incorporated. A lot of the times is because the board wants you to incorporate them. So you have to find ways in which to incorporate that into your regular workflow. Um, but that's something that we do in academia as well, right? We learn of a new technology that's probably going to help us with our research. And we talk to our PI, and if there's funding, we can, bring in people from that company to do a demonstration, or you buy the new platform and you incorporate it. So this is not something that only happens in industry. We know how to do that. We know how to be adaptable to new technologies. Another big thing, and this is more so in industry specifically, uh, projects, goals, and deadlines shift all of the time. And again, this is dictated by the market, by what's creating revenue for the organization, right? So if you have a project where you're not creating revenue, the board is more than likely going to kill it. So you'll have to move on to the next thing. Okay, so what to expect? So the biggest thing for me was the change in mindset, right? You're not doing work just to know more about it. It's not about knowledge. It's about a lot of the times in industry, it's about money. You're in the corporate world, right? So you always have to have that at the front of your mind once you make the move to industry. The projects that you're working in, the projects exist because there is the potential to create revenue. If that ceases to be the case, that'll probably change, right? So that's the mindset. It's going to be about money. You have to adjust to a faster paced environment. As I said, the projects change, and you get new projects every couple of months or so. It's rare to have longer term projects such as the ones we do in academia. You also have to learn industry specific jargon and workflows, and this will be very specific to each company. In the pharmaceutical industry, for example, you have to learn what GMP is, for example, greater manufacturing practice. But what does that really mean? That means that you have to document literally every single step that you take to do an experiment, right? And it has to be documented in a very specific way. And that's just the way it is, right? If you're in, for example, in the sales and marketing team, you talk about different terms. So you always have to adjust to what your industry role, the jargon for that is specifically. You also have to learn how to navigate non-research roles. So there are many people in an organization that will probably have nothing to do with science, and you have to learn how to work with them and how to probably make them see that what you're doing in the lab is something that they should care about, for example, or that the company should care about. So you have to learn how to work with these teams. You also have to adapt to, as I mentioned before, changing deadlines and project goals. This will happen all of the time. And as I said, it's faster paced. And you have to understand the differences between established companies and startups. I had no idea how different a pharmaceutical company would be to a startup. And it is very, very different. So you have to, if you're thinking about making the transition, you should think about where you think that you as a scientist would thrive most. If you like to, follow the recipe of an assay and do it over and over again, pharmaceutical companies are great. Those jobs tend to be more stable. You know exactly what you do, but the job can be repetitive. In startups, on the other hand, is very chaotic. You have to, as I said, you have projects that last a couple of months because you're trying to determine whether or not they're going to be commercially viable. And if they're not, you move on to the next thing. So the vibe is very different. Okay. So what I do now as an application scientist is, as Michaela mentioned in the introduction, I develop workflows for automated wholesale patch clamp instruments. Well, it's just one instrument, right? And I'm trying to, from the literature, I still have to look into the literature a lot and then look at market trends to see what I specifically work with ion channels and what therapeutics are targeting which ion channels. Yes, Michaela, you have a question?
Yes, sorry. I just wanted to, for the sake of time, would it be possible
I'm
to...
talking a lot.
No,
Sorry.
no, no, it's fantastic. It's all incredibly valuable. But we do want to save a couple minutes for questions. Do you want to
Yes.
wrap up this slide and then we can open the floor for questions?
Well, all I wanted to say is that my job as a scientist here depends on stakeholders. I just don't get to be in the lab and do whatever I want. Okay?
No,
So it all
perfect.
depends
Thank
on
you.
what the
Sorry,
projects are.
I didn't
Yeah,
want
that's pretty
to
much
rush.
that's pretty much the take home from this slide as an application scientist, and this is just one avenue that you can take. Okay.
Perfect. Thank you so much.
So to make the leap, it is very important to leverage the transferable skills that you have from your academic work, and those are all of the skills that I spoke about earlier. It's really good if you can do your research and understand the different roles that you as a scientist will fit in the best, right? Lab work is not the only work. If you want to get out of the lab, there are many opportunities out there. You have to be open to entry-level jobs. Just because you have a PhD and you become the expert on a particular subject does not mean that you will be the expert once you go move into industry. And you have to start at the very beginning, which is an entry-level job, and that is okay. Tailor your CV to industry roles. You can't just send one whole CV all of the time. You have to tailor it to what the job description is and what skills they're looking for. So you do have to put time into that. And network. It is super important to connect with people from industry because those might be the people that will help you find your next opportunity. And once you're in industry, it is very important that you build an emergency fund because of the job instability that I was talking about earlier. So I think the presentation is going to be available later, right? So these are some of the options that you have in industry. So you can reference this later, but as you can see, these are not all. There's a lot that you can do. Okay, so key takeaways. Flexibility is crucial to success. Industry values problem solvers with strong communication skills, period. If you cannot communicate what you're doing or what you need, it's going to be very hard to thrive in an organization. And this is sometimes more important than technical skills. As I said, you'll be taught how to do experiments in a completely different way. Okay. You have to understand that you'll be constantly learning and then you'll have to adapt. But this is no different than what we do in academia. Take time to research companies and roles. So with startups, for example, there's a higher risk that the company will not survive. So look into what stage of funding they are, where they are in their revenue targets. And during an interview, you can ask these questions like, what's your cash runway? So that you have an idea of how long that company is going to last for. If you're looking at a pharmaceutical company, you can ask, what project am I going to be working on, and or how long will that project go on, and what will happen after that project's done. Okay, so that you can understand whether or not they're just looking for somebody to work on that project alone, or if there are avenues for you to move into something else within the same company. And again, entry level positions are okay because you will start at an entry level position. A PhD does not mean that you will become a director immediately. That's way, way down the line. Okay. All right. So I'm happy to take questions. I'm sorry I took so long, even though I said I wouldn't, but that's my email address. I'm happy if you email me and ask any questions that you have. It'll take me a couple of days to respond, but I will respond.
Perfect. Thank you so much.